natural numbers to solve problems. This was the right set of numbers to work with in discrete math because we always dealt with a whole number of things. The natural numbers have been a tool. Let's take a moment now to inspect that tool. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. What mathematical discoveries can we make about the natural numbers themselves? This is the main question of number theory, a huge, ancient, complex, and above all, beautiful branch of mathematics, my personal favorite. Historically, number theory was known as the queen of mathematics and was very much a branch of pure mathematics, studied for its own sake instead of as a means to understanding real-world applications. It was fun. This has changed in recent years, however, as applications of number theory have been unearthed. Probably the most well-known example of this is RSA cryptography, which is one of the methods used to encrypt data on the internet. In fact, pretty much every form of security on the internet relies on facts in number theory. It is number theory that makes this possible. What sorts of questions belong to the realm of number theory, though? Here is a motivating example. Recall in our study of induction, we asked the question, which amounts of postage can be made exactly using just 5-cent and 8-cent stamps? We were able to prove that any amount greater than 27 cents could be made. You might wonder what would happen if we changed the denomination of the stamps. What if we instead had 4 and 9-cent stamps? Would there be some amount after which all amounts would be possible? Well, again, we could replace 2 4-cent stamps with a 9-cent stamp to get 1 more cent, or 3 9-cent stamps with 7 4-cent stamps to get 1 more cent. In each case, we can create 1 more cent of postage. Using this as the inductive case would allow us to prove that any amount of postage greater than 23 cents can be made. What if we had 2-cent and 4-cent stamps? Here it looks less promising. If we take some number of 2-cent stamps and some number of 4-cent stamps, what can we say about the total? Could it ever be odd? Doesn't look like it. Why does 5 and 8 work, 4 and 9 work, but 2 and 4 not work? What is it about these numbers? If I give you a pair of numbers, could you tell me right away if they would work or not? We will answer these questions and more after first investigating some simpler properties of numbers themselves. So I'll see you in the next following lectures.